I am Aldo Dagnino, and I'm the Director of Applied AI in Computer Science and Engineering. And I'm honored to be with you. And I would like to invite our next speaker, Dr. James Lester. And he is the Goodnight Distinguished University Professor in Artificial Intelligence and Machine Learning in the College of Engineering. He is the director of the Center of Educational Informatics and the director of the National Science Foundation AI Institute for Engaged Learning. Dr. Lester is the recipient of a National Science Foundation Career Award, 4 Best Paper Awards, and the International Federation for Autonomous Agents and Multi-Agent Systems Influential Paper Award. Please give a warm welcome to Dr. James Lester. Thank you.
Terrific, thank you. It's great to be here. I see lots of familiar faces and also some unfamiliar ones, which is a nice balance. Where is Ray? She stepped out. I just want to endorse her 3-day weekend proposal. This is very attractive, and if AI can give us anything, surely it can give us an extra day. So I'm delighted to be here to share with you maybe a different area of AI than we've been exploring so far. So we know that AI is going to impact everything. So it's going to have a very, very significant effect on every sector of society. And Ray, I just endorsed your 3-day weekend. Thanks for that again. We have an opportunity to really change how we do business. And when I say that, I mean here for education. So AI has emerged as this incredibly powerful family of technologies, as we've been hearing about all day. AI is changing so quickly, none of us can keep up with it. None of us can really predict what the future holds. But we also know that this is beginning to have this effect across society. And personally, I used to wake up in the morning and I would read the New York Times and it would be very exciting and I would be prepared for the day. Now I wake up every morning and I read the New York Times and it's filled with AI, which is my own field. And it's very exciting and I don't feel prepared for the day. Well, we're now at this kind of crossroads in education. So we're seeing AI accelerate so quickly. I don't know if you guys are familiar with the Stanford AI Index. It's absolutely the best single source. If you need to read something, just one publication, I would recommend reading this. So we now know that AI is exceeding human performance in many different arenas, not all, but many. We also know, as we just heard from this great panel discussion, there are going to be very significant labor effects. So workforce changes beyond what we can really imagine. There are, of course, emerging studies that are showing that AI can improve human productivity, the quality of work, the efficiency of work, but it's a little uneven. So right now we're also seeing really, really clear indicators that AI doesn't, in its current state, help everybody. And so, there's some really interesting things to look at there. AI and STEM, so this is very much what this gathering is about. AI affecting every single area of STEM. One of my favorites, and this is a sort of meta point, is a kind of flywheel effect that we're beginning to see. So AI is, of course, being used to design chips. AI is being used to design software. And, of course, AI can be used to design AI chips and AI software, which has this sort of virtuous cycle of much more rapidly improving the sort of performance of AI than we would have otherwise seen. And the effects of that are hard to predict. And then, of course, all of this against the backdrop of just an enormous, enormous investment in AI. Much of it in North America, a good bit in Europe, but globally really changing everything. There is a sort of immediate effect that we can see of all of this. Kevin Kelly. How many people have heard of Kevin Kelly? So Kevin Kelly was one of the original editors of Wired. And Kevin Kelly says very wise things. And one of his turns of phrase, and this is actually like maybe 5 or 6 years ago, he described this sort of emergence of AI that we were seeing then as the cognification of everything. And I think that's a really good metaphor. So we're really going to be seeing it appear in everything that we do. And in particular, we're going to be seeing it in education. The reason I'm here talking with you about education is that this is kind of my home field. So this is a field I've been working in for, gosh, over 30 years now, which is very hard for me to believe. Most folks know that AI started like 1955, 1956, 1957. There was some, post-World War II era AI. Actually, the field of AI in education started not that long after that. It started in 1970. So we've been going at it for a long time. My feeling about our field is that first, it's a really, really exciting area to be working in for the sort of societal impact that we're almost certainly going to be seeing, if not immediately, certainly over the next couple of years. Second, it's exciting because this field, because it's been around so long, we understand the problems. We sort of know the phenomena that we're trying to support, which is to improve human learning. We want to make learning more effective. We want to make learning more engaging. Sometimes for training, we want to make learning more efficient. These are all really important and very complex phenomena, but we have a really strong sort of evidence base within AI in education for the kind of vector that we're heading toward. Now, the question is, why is that? So I want to take just a couple of minutes to describe what I think of as kind of the canonical, most sort of accepted vision of what AI in education is about. And then I'd like to spend maybe the last 15 minutes of this discussion helping us kind of peer into the crystal ball, into the future, about what's really, I think, even more exciting than this. Okay, so AI in education. One thing that many people are, I'm going to do this quickly. One thing that many people are surprised to learn is that there is a model for really good education. And this model is one-on-one human tutoring. So there are hundreds and hundreds of studies over decades demonstrating that one-on-one human tutoring is at least 2 standard deviations better than kind of regular classroom learning. And why is that? Well, there's kind of an adaptive coaching component to it, right? So how many people have been tutors in this room? Wow, many of you. Wow, that's great. How many people have been tutored? Not as many people are admitting this, but many, many of you have been on one side or the other or both. Personally, I've been on both. I switched schools when I was in elementary school that sort of made me skip a grade because of the school change. And so I spent a summer being tutored. I look back on that very fondly. It was math tutoring. But also, it sort of gives you, if you're a tutor or a tutee, it gives you intuitions for why human learning works and what kinds of supports can make it work even better. And adaptive coaching is one of the reasons here. Interactive problem solving. So many people in this room are engineers, so we all sort of experientially appreciate the value of interactive problem solving. Conversational interactions. We're now living in the era of LLMs, so it's really apparent why conversational interactions could be supportive of learning. One that's maybe a little bit less evident is affect. So there's a whole field of affective computing that you might be familiar with. So this is computational models of emotion, models that can understand when people are experiencing a particular emotion, recognize it, being able to synthesize sort of visual manifestations of emotion. In particular, for certain kinds of learners, I'll include those that are young, but also those that are needing motivation. Affective modeling can really make a very big difference in the effectiveness of, in this case, one-on-one human tutoring, but you can imagine kind of the computational counterpart of this. Metacognitive support. So, we all know that self-regulation and metacognition are really key, particularly as we're training people to learn, which is going to be probably the most valuable skill everybody's going to have over the coming decade and beyond. Motivation. So gosh, a really good human tutor is incredibly motivating. If you've ever watched somebody, as an observer of tutoring happen, you know the kind of spark that a really good tutor can elicit in a tutee. And it's just exciting, and there's something deeply human about this, and it's really fun to see. All right. So what if we could have kind of the AI counterparts to this? This is, I should say, the kind of metaphor that has driven much of the work in my field over the last, since 1970, I'll do the math, 50 plus years. And it goes like this. So what would be required to kind of computationalize this? A key task in AI in education is called student modeling. So how do you develop models of students' learning? So models of students' reasoning, models of students' problem solving, models of students' competencies. What do students know? What are their current problem solving goals? How are you able to kind of recognize the strategies that they're undertaking? And the list goes on. There is a very deep understanding of this because we have a deep understanding in the learning sciences, education research more broadly, of what sort of makes students work. But being able to do this in real time and to be able to do it accurately, it's a challenging problem and a really interesting problem and kind of core to this enterprise. A second one is pedagogical planning. So if you were a tutor, one thing, especially if you were a good tutor, one thing that you were very good at was being able to make decisions about how do you kind of orchestrate the learning process. So when do you provide a hint? How do you provide an explanation? When do you decide to pose a particular kind of problem over a different kind of problem? What's the timing of all of that? So these may seem self-evident, and tutors are actually very poor at being able to articulate the approaches that they use, but in fact, it's exactly that decision-making that makes up pedagogical planning. It's a famously hard problem. Domain modeling, of course. A good tutor has to have a good understanding of the domain that they're tutoring, and that's absolutely the case for AI models. Intelligent user interfaces, sort of writ large. How do we develop a system that has all the functionalities to support these interactions that we know that human tutors are really good at? Of course, natural language understanding is completely key to this, so is dialogue management, natural language generation, speech, both directions. So you might be thinking, gosh, this is all a kind of non-signal processing problem, but it's actually very much a signal processing problem too. So computer vision certainly comes to the fore. And then all of this, just like all of AI, is deeply driven by ML. And the better ML gets, the better all of these functionalities get, and the better tutors that we get. And then I'll just quickly mention something before kind of moving to the main topic of my talk, which is many people in this room are instructors. And one of the guaranteed changes that we're all going to experience, and it's going to be kind of bumpy but really interesting, is dealing with this new world where a student has a kind of something like a tutor that they're working with, and then maybe another student has one of these, and maybe the whole darn room, and then maybe it's actually not maybe, because they will. So what do we desperately need? And here I'm speaking on behalf of all of us. We need one of these for us. And so a really, really fun problem that this field is working on is, gosh, how are we going to be able to develop teacher supports for us as instructors? Okay, so that's the vision that this field has had since 1970. It is an admirable vision, in my view. It's very exciting. As I said, there are decades of results. We now have this very new, exciting set of tools that we're getting to use to work on these same kinds of problems. But what I'd like to make the argument for is, in fact, this is really just the sort of tip of the iceberg. There are lots of even much more, in my view, enticing metaphors that we want to be looking at, sort of different ways of learning. So that's what my group has been working on for the last 3 years. How many people know the NARI program of NSF, the National AI Institute's research program? Any, one, two, like a few of you. It's a great program. So NARI was launched like probably 4 years ago by NSF, and it's a really interesting funding mechanism because it doesn't just, and I say just in quotes, it doesn't just fund kind of core AI. So it would have been really easy, I think, for NSF to have sort of followed their standard funding model and provided support for, kind of deep in the stack ML and so forth, and we would have gotten some really interesting results out of that. However, they took a much different approach, and that is a kind of combination of use-inspired work and core AI work, right? So sort of foundational and application-oriented. And they've done this in a very disciplinarily, if there's such a word, oriented fashion where there are AI institutes for different disciplines. So there's an AI institute for physics. There's an AI institute for meteorology. There are multiple AI institutes for other sciences. There's one for chemistry, for example. There are multiple ag AI institutes. Actually, just today it was announced we have 2 new astronomy AI institutes, which is really exciting. So you can sort of see the pattern. Now, one of the things that I find most exciting is that NSF decided that they would treat education very much like these other fields. And so they've invested in multiple AI institutes for education. And the one I'm going to describe briefly here is one of those. So the Engage AI Institute, we launched 3 years ago. This is an institute that looks at sort of broadly the really interesting problem of how we can get AI to generate narrative-centered learning experiences. So these are story-based learning experiences where students are solving problems. They're doing it collaboratively. This is for classrooms. Of course, it can also be for outside of classrooms. And we're really interested in what does it mean to advance both this sort of use-inspired side that I'm describing here, but also the underlying technologies of ML and NLP and computer vision. And there's 3 areas that we work in, which I'll describe in just a second. But I also want to say that just as I was mentioning before around this need for support for instructors like us, there's also a need for instructor support for K-12. And being able to both support students and instructors in K-12 really has the opportunity to be game-changing, and I don't use that phrase lightly. I want to give you just a sort of super quick cook's tour of the Institute. And I'm going to do it quickly because I want to save time for discussion at the end. So the AI Institute, the Engage AI Institute, is a partnership of 5 organizations. We're headquartered here at NC State in the Department of Computer Science. We have collaborators at UNC. Most of our core AI collaborators are at UNC. Vanderbilt is one of our other partners, also Indiana University, and then Digital Promise. Digital Promise is a really interesting nonprofit. It's called a congressionally originated nonprofit. It was birthed by Congress. And Digital Promise is a very, very large organization with connections to schools, nonprofits, philanthropic organizations across the country. It's a great team, and I don't say that just because it's in our institute. These are really wonderful people. There are kind of 3 sorts of folks who are part of the team. One are people who are kind of like me. So these are people who are really in between AI and education. So I think of myself and I think of several of my collaborators as kind of being on the fence, having kind of one foot in AI and 1 foot in education. Then we have our core AI folks, NLP, ML, computer vision. And then we have our education researchers, so learning scientists, STEM education folks, people who work on instructional design, all kinds of people who, when they come together, do super interesting, I think, things. We have three strands. So our first strand is AI-enabled narrative-centered learning. We'll see some examples of this. The second is narrative-centered collaborative learning. So one of the things that many people think in this age of AI that we're entering that's going to be incredibly important for our students is the ability to collaborate. So this isn't just a sort of nice to have platitude that it seems like it would be good to put on a slide. This is going to be incredibly important. There's some argument that the ability to collaborate, whether it's with other people or with AIs, may become kind of the single skill that's most at a premium. And then multimodal analysis, so being able to take all the very, very rapidly emerging multimodal technologies, extend them, and then use them for multimodal learning analytics. So now I'm going to move into really, really rapid syllables per second, but just to give you kind of a sense of some of the work that we do. The kind of driving force of the Engage AI Institute is narrative. So as you probably know, there's something really central to narrative. It's not an accident that we all love reading stories, that we all love watching films. There's something that's deeply, deeply captivating about narrative. We've known this for a very long time, but it's also true for learning. So you can imagine that if you could have groups of kids in a classroom, we primarily work with middle school students and primarily with STEM, but you know these technologies are kind of much broader than that. So really interested in these kinds of questions of how can the technologies generalize across different student populations, different learning contexts, different ages, different subject matters, all super interesting, but really focused on narrative. So if you could have, this is the kind of core hypothesis that we're exploring, if you could have AI in many, many different manifestations that could support students' problem solving as they're working collaboratively, and you're able to control story world and plot and characters in really interesting ways, and we'll see kind of an example of that in just a second. Might you be able to create learning experiences that are really effective? And I'll just super quickly say what I mean about that, but also engaging. Now, when I say effective, there are some things that, because we work with K-12 public school systems, that really come to the front. So we have to be able to demonstrate that these technologies are helpful. And one way of measuring that is learning gains. Another way of measuring that is motivation. So how do we know that we're creating experiences that are motivating? And then sort of backing off of that, how do we create experiences that are deeply collaborative? So there's an enormous literature on collaborative problem solving and collaborative learning. So how can we use instruments that are developed in those fields to assess collaborative problem solving through dialogue and so forth? And how can we measure engagement? So this question of how you measure engagement, in addition to how you support it, is a super interesting problem. Gosh, what is engagement? Well, again, there have been decades of work on studying engagement and learning, and there are instruments that have been developed for this. It's still kind of an open question, but really interesting. All right, so now what I'd like to do is to quickly, and I want to make sure this is not too loud, just share a couple of examples of the kinds of things that we're working on. And I should say that one of the real interesting questions in this kind of new type of AI in education, as opposed to the old type, which is still interesting, the sort of one-on-one human tutoring, is how do you do what was the equivalent of pedagogical planning back here, but now is sort of pedagogical narrative planning. So how do you create a system that can dynamically create plans to support students' interactive problem solving in narrative? Reinforcement learning is one type of model that we're exploring. We're also looking at LLMs. Now I want to make sure I can play this video for you. And do so where it's not too loud. Oh, great, not too loud. All right, so imagine that you're a middle school student and you're working in a classroom and you're working with your, I'll call it your collaborators. So imagine teams of like 3 or 4, and you're working in this sort of science mystery, right? So suppose that you're trying to understand, ultimately what your teachers are wanting to understand is microbiology, but suppose what you're trying to do is to diagnose a disease that's broken out on an island. You sort of don't know what's kind of the cause of this disease. You're trying to learn about, gosh, what are the symptoms that your research team has been experiencing. And behind the scenes, suppose that there is a system that's making narrative plans. So it's making things like decisions about which particular plot points should be sequenced in a particular order. It's making decisions about, gosh, what should characters be doing? It's making decisions about how the characters should interact with each other and interact with you as the student. One of the super fun things about this area of work is that there is a subfield, and really it's kind of a subfield of AI that's been around since 1999. And it's called Narrative Intelligence Community. And this is a community that works on this very fun problem of being able to dynamically generate narratives. It could be sort of offline, or it could be online, it could be sort of one-shot, it could be interactive. And doing so in a way that's maybe not just generating text, as this is doing, but also generating adaptive support for students as they're doing it interactively, and it's an immersive experience. So this is kind of the vision for the kinds of things that we work on. I now want to zip ahead to another example, which is, for me, starting to approach science fiction. So when I was a kid, I was a major fan of science fiction, very, very, very into science fiction. And I have to say that something like every, I don't know, 5 or 6 weeks, I'll be in a meeting, an AI Institute meeting, and I'll get like little tingles of that same thing that science fiction set off when I was a kid. This is one that routinely does it. And I'm going to describe it, I'll try to describe it in like 3 sentences. Suppose that you wanted to have the kinds of interactive narratives like I just showed, something like that. But suppose you wanted to have somebody design one of those that had no technical experience, did have some pedagogical experience, but they had no sort of design capacity, right? So they didn't have any, and you can think of somebody like a teacher. Would that be possible? So there's some, I think, really, really interesting work going on in the Institute on exactly this problem. We'll see if I can play it. Great. This is the problem of narrative generation. What if you could have a system that would let somebody type in natural language? And I should say these are prototypes. These are not fully fielded out in the world or anything like that. These are really, really, really exciting sort of glimmers into what we're going to be seeing. And I think it's going to be very likely that over the next something like probably less than a year, we're going to be having versions of these kinds of technologies that teachers will actually be able to use. This particular system is called SceneCraft, and it supports exactly that. So there's a tiny little, to me, just amazing, simple natural language entry of what you might think of as specs for the system. There is then this kind of process of generating the kind of character dialogue. They're actually blocking, and by blocking I mean in kind of a theater version of blocking problem to solve. Then there are interactions with characters, and then the system sort of goes off and generates this. And the person who's really responsible for this particular project is Vikram Kumaran. Vikram is a particularly interesting person because he's been working in interactive narrative on and off for a very long time. And we're seeing, I think, some super promising effects here. Let me go forward. So I want to take 2 minutes, and now there are going to be some subliminal slides, okay? I want to quickly skip ahead to a quick multimodal example. So I don't know if there are any social scientists in the audience today, but a major problem in all of social science, and this is true for education as well, is how do you analyze gigantic volumes of video data, in this case of students interacting in classrooms, problem solving. So it's a very, very famous hard problem that folks in education have been grappling with for decades. And I'm not joking, it's seriously not uncommon for a research team that's working on qualitative research in this area to do a data collection and then literally for 10 years work with this piece of video. Maybe it's like an hour-long video trying to understand what's going on. That's quite literally not an exaggeration. So one of the really fun things that we're working on in the Institute is addressing that problem. And no coincidence, there's been this proliferation of work in multimodal AI. And one of our collaborators, Mo Bansal, has been working in this area for a long time. So just imagine being able to have a system that could understand a natural language question about a piece of video. And when I say a piece of video, I actually mean like an hour-long video. And it may sound simple, but kids, working collaboratively in a classroom, say a classroom full of 30 kids and a teacher who's wandering around, oh my goodness, that is very, very, very difficult to analyze. But that's exactly the problem that ed researchers have to face. So for example, an ed researcher might say, show me when the teacher walks over to a group of students and asks a question about scientific concepts. And there's an hour of video that the system has to go through. We're seeing that it's actually possible to do this and even to identify particular clips. So we'll see if we can see a quick example of this.
This is where you guys are discussing the oxygen cycle. You're taking a look at
the system has gone through, all the stuff that was going on in the classroom. It's making decisions, not in this particular case, but about student gesture, students' locations in the classroom, students' dialogue. So there's a very strong NLP component to this. Decisions about who's interacting with who. And I want to show one other example. And the thing I most want you to take home from this next example, so the question is, if I make an example of a student who's encouraging another student, and what I want to show you here is the system finds this out of all of the stuff that's going on in the classroom, and it's going to sound like this video is garbled, okay? That's because the video is garbled. It's just very difficult to hear. This is very, very low quality capture of the
You're not there, Uncle. Oh, yeah. Sorry.
of what they're doing. But one kid is actually saying an encouraging thing to another kid, and if you listen really close, you can hear it. And it's kind of like magic, I will say. All right. So wrapping up. What I'd like to leave you with is this sort of like core AI idea of ubiquity. So we're going to be seeing classrooms that are kind of like the one that you see here on the right. And what do you see that's special about it? The answer is nothing. You don't see anything special about it because AI is so deeply embedded in it, we can't see it anymore. My PhD advisor, who actually is visiting tomorrow, always used to say, and this was like 30 years ago, AI in the future, nobody will even notice it anymore. And I really feel that we're approaching this. It's a different version of singularity than Ray Kurzweil talks about, but I think it's absolutely the case. And the final thing I'd like to say, and this is sort of a request for you, as instructors, as parents, as influencers of the public discourse, really, really make the argument to your school boards, to policymakers, to teachers, to administrators, that we must educate our students about AI. So clearly, our students are going to be living in these AI-enabled worlds. It's going to be really exciting. But these competencies of being able to collaborate with AI, to have an appreciation for sort of the kind of ethical foundations of AI, those are going to be just central to making sure that we have a thriving society and sort of more broadly, a thriving world. So lots and lots of exciting stuff coming in AI and education. Thanks so much for your attention, and it'll be fun to chat.
Thank you very much, Dr. Lester. We have some time for questions, 7 minutes. So whomever has a question, please raise your hand and I'll bring a microphone to you. Yes.
Hi, this is Sandeep Kuttal, Computer Science Department. Just a question. I saw that most of the stories are around health. Is there any around engineering or problem solving and creativity, and how those stories are generated?
Those are great questions. One of the things that we try to focus on in the Institute is STEM education for K-12. We have several learning environments, so we're always, across the Institute, working on different subject matters. So there's one for ecosystems. There's another one for microbiology. There's another one for food justice. It's actually it's a pollination unit subject matter that's under the umbrella of food justice. But the creativity one is super interesting. So one of the ideas that we're playing with now is what if we could take those scene craft technologies, that's the example of the narrative generator. What if we could take those, and we've been thinking about this for the last 3 years as being a support for teachers and instructional designers, to create kind of customized narratives for their classrooms. But what if you could have kids doing that? So what if you had kids being kind of the creators? And I think it's this sort of like co-creation metaphor that's going to be everywhere, over the next 30 years. And it's really interesting to think about. So if you wanted to create a system that would really cultivate these sort of creativity kinds of competencies, then maybe something like a scene craft for kids could be possible.
Hi, this is Shia from College of Ed. Thank you so much for the cool presentation, Dr. Lester. So I have a question about the intersection of AI in education and AI education. Thanks for bringing up the AI education at the end. I want to have your insights in terms of the study of the intersection of these two in the education field, and in general that it's critical for students to have some kind of AI literacy in order to use these kind of systems, and how transparent this system should be. For example, your Engage AI platform, the student really need to understand how that functions in order to interact with it. Thank you.
Thanks, Xian, and also congratulations on your new grant. There's this really kind of funny terminological point. As I said, the field of AI education has been around since 1970, and it's been called AI education, AI ed, for all of these years. But now, and this is what most of the work that I described here focuses on, so AI technologies for education. Now, there's another whole interesting field. So just like there's math education, and there's physics education, and there's chemistry education, there's also now AI education. So we need to develop sort of the pedagogies and really understand kind of learning progressions for AI. I'll mention that not part of this institute, but in other NSF-supported work, collaborators at Indiana University and our team have been working on an example one of these projects. It's called Primary AI. So it's looking at the question of, gosh, how could you teach AI competencies to elementary school students, which is kind of a fun problem. The really interesting puzzle here is, gosh, how might you best sort of sequence AI content for kids all the way across the curriculum? So there's the technical side of it, which of course for almost everybody in this room is really, really interesting, and that's why you're here. But there's also the kind of societal side to it. So, AI ethics crosses over both of these. There's this emerging field of AI ethics, which is really exciting. And then finally, I'll say that there's this kind of meta answer to your question, which is you can absolutely, and people are beginning to look at this, use AI to teach AI, which, I don't know, it's kind of cool. Thanks.
Right here. Thank you for the presentation. Suppose hypothetically you had a dean who was really excited about AI and wanted to invest in tools like this for some of our hardest classes. I'm thinking of statics, thermodynamics, circuits, where we see a lot of the students, dropping out of engineering or switching to other majors. How much do these tools rely on sort of the existing domain knowledge that's accurate? I'm thinking of basic science, elementary mathematics. The large language models are getting that right at a very high level. You go into the deeper disciplines where there's not as much stuff online for these models to have been trained on. It maybe causes some more concern. So what are the prospects, in the next 5 years of having this version for statics, for example, be an area of?
Well, it is a totally hypothetical scenario you're weaving here, but if there were such a dean, probably what I would tell him or her would be that I honestly can't imagine in 5 years that these are not in use in every classroom. I mean, it is all but certain. There are technical challenges between now and then. So the famous, very, very, very difficult hurdle that this field of AI in education has had since its inception is authoring. So authoring the domain knowledge. It is not the case that LLMs have sort of made that evaporate. Hallucinations are real. I think that's a funny way to describe it, but hallucinations are real. And really trying to take LLMs and incorporate pedagogical knowledge is a non-trivial activity. So really trying to train them, and what do you train them with? There's all kinds of interesting questions there. But the sort of super short answer is that we're going to have them. Like absolutely, it's going to be a beautiful world.